we'll see the relation between arrays and pointers. If I declare an array integer a of 5 elements, as we have seen in the earlier videos, it is going to allocate here 10 bytes for storing 5 integer values. So when you give an int a of 5, assuming that each integer is occupying 2 bytes, so total 10 bytes has been allocated for this array. So each and every location is identified by a unique index number starting from 0. So 0, 1, 2, 3, 4. Okay. We refer this first location by giving here a of 0. Second location is a of 1. Third location is an a of 2. Same way a of 3 and a of 4. If you want to read all these location values, the code we write here is declare an array int a of 5 elements and one variable for generating an index variable. So enter 5 integers, generate an index number starting from 0 to 4 and give here scanf %d ampersand of a of I. So this will read here 5 integer values. Let's assume the value given in a of 0 is 10 and a of 1 is 20, same with 30, 40 and 50. To display the first location value, we can give printf a of 0. Second location value can give an a of 1, a of 2, a of 3. Okay, this is what we have discussed till now. Now internally, what is this arrays? Arrays internally are nothing but pointers. When you declare an array, internally a pointer gets created. Internally what happens here is, there is a pointer with an identifier called as an a. So when you give an int a of 5, internally this a is a pointer here, and that also it's a constant pointer whose value cannot be changed. And this pointer will hold only the first location value. Let's take up the first location starting address is 1000. 1000. The second location is on 1002 because each integer is occupying 2 bytes. 1000 and 1001 is been allocated first location. So 1002, third location is at 1003, fourth at 100. Sorry, this is at 104, and this is at 1006, and this is at 100. And this A will hold the first location address. The first location address here, it is on 1000, so that is going to be stored inside this A, and that means it's going to always point to the first location. And its value cannot be changed, so hence I call it as a constant pointer. So whenever you create an array, internally a pointer gets created. And this is an implicit pointer. You have not created implicitly, automatically the compiler is going to create. So I call it as an implicit pointer, and it will be always pointing to the first location. So whenever I give here a of 0, what it does is it takes as asterisk of a plus 0. So we have seen in arithmetic operation on pointers, that is, if I take an integer pointer, and if this pointer is having an address 1000, and if I give here p plus plus, the p value gets incremented by 2. That means it's going to be a 1002. Same way, if you take a float pointer, and if that float pointer is having a value 1000, and if you give her now p plus plus, okay, in that case p value is going to be 1004. So integer pointer gets incremented by 2, float pointer gets incremented by 4, character pointer gets incremented by 1. This concept is used in arrays here. So when you give her a of 0, internally it takes as an asterisk of a plus 0. So here asterisk of a plus 0. A plus 0 is what? A value is 1000 plus 0. So integer pointer plus 0, it's going to be nothing but here 1000. And asterisk of 1000, that gives you the value 10. Same way when you give a of 1, internally it takes as nothing but asterisk of a plus 1. So a is 1000. So 1000 plus 1, it's going to be a 1002, and asterisk of 1002 will give that 1002 location value. Same way, a of 2 will be internally taken as an asterisk of a plus 2. So 1000 plus 2. So 1000 plus 2, it's going to be nothing but your 1004. Each integer is when you increment integer point, it gets incremented by 2. So you are incrementing by 2 means it gets incremented by 4. So 1004. Asterisk of 1004 will give you 30. That means for displaying, instead of giving here a of I, you can also give it as asterisk of a plus I. So both these are same. Okay. So you can give it as an a of I as well as you can give it as an asterisk of a plus I. So for displaying an array elements, you can write a code like this. So you have read the values, printf array elements are, take a for loop, I equals to 0, I is less than or equal to 4, I plus plus, and here you can give it as printf /n %d and you can give here a square bracket of I comma as well as you can give here asterisk of a plus I. So both these places you will get the same value. So if a of 0 value is 10, so asterisk of a plus 0 also will display 10. When I value is 1 and a of 1 value is 20, so asterisk of a plus 1 is also going to be 20. Right? So that means internally arrays are nothing but pointers. Whenever you create an array, a constant pointer gets created and it will be always holding the first location address. Its value cannot be changed. Fine. Now I have given here a plus I or a plus 0. So what is the difference between a plus 0 and 0 plus a? Okay, that is equivalent of giving here what is the difference between 10 plus 20 and 20 plus 10. So 10 plus 20 is also 30 and 20 plus 10 is also going to be nothing but 30. That means a plus 0 and 0 plus a both are same. That means I can also give here asterisk of 0 plus a. I can also give here as 1 plus a. Same way 2 plus a. That means instead of giving here asterisk of a plus I, we can also give it as an asterisk of I plus a. So all these three are same. That is, you can give it a of I, asterisk of a plus I, asterisk of I plus a to display all the array elements. All three are going to be same. Okay, so here we'll just add one more printf statement. Printf %d, and we can give also as an asterisk of I plus a. All three is going to display the same values. Fine. Now I'm saying here a plus I and I plus a plus I and I plus a both are same. That is, I said when you give a of 0, internally it's going to take as an asterisk of a plus 0. When I give a of 1, internally it's going to take it as an asterisk of a plus 1. So do you mean that instead of giving here 0 of a, can I give here 0 square bracket of a? Same way 1 square bracket of a, 2 square bracket of a. Okay, that is, can you give here I of a? Is this possible? Yes, even this is also possible. So when I give here a of I, internally it takes as an asterisk of a plus I. When I give I of a, same way here also it's going to take as an asterisk of I plus a. That means when these both are same, naturally this also has to be same. That is, you can give here even I of a for displaying all their elements. It's not that all the time you need to give it as an only a of I. Usually in the textbooks everywhere we try to just give it as an a of I. So you can also give that is I of a. These all things are possible just because there is no difference between pointers and arrays. Pointers internally there is nothing. Arrays are internally it is nothing but an pointer. So that means you can also give here as one more %d and then give here I of. So let's just enter this code in a code block and see what will be the output. Okay, fine. So we'll see the output of it. So I have declared an array here, a of 5 elements and an integer variable. So I'm asking the user to enter 5 values within this loop. I equals to 0, I is less than or equal to 4, I plus plus, scanf %d, ampersand of a of I. Whereas array elements have been displayed with all the 4 ways here. Array elements are I equals to 0, I is less than or equal to 4, I plus plus, and I have given 4 percentage D here. Percentage D, percentage D, percentage D, percentage D. And here it is A of I. I've given I of A, asterisk of A plus I, and asterisk of I plus. Okay, fine. Let's compile this code. Fine, there's no errors, 0 errors, 0 warning message. We'll run the program. So it's asking for the 5 values. I'll give the values as 10, 20, 30, 40, and 50. So this 10 is stored in A of 0, 20 is stored in A of 1, continuous ladder. And when you press enter key here, and you can see here, this column, first column, we have displayed with by giving here A of I. Okay, you can see here, we have displayed by giving here A of I. Okay, that is as usual. Whereas second column has been displayed by giving I of A here. I of A. That means it is giving the same value as A of I. Third one is asterisk of A plus I. And then fourth one is an asterisk of I plus A. That means all these 4 are going to be same. A of I of A, asterisk of A plus I, and asterisk of I plus A. Asterisk can be used provided if it is an address. If it is a pointer, pointer will hold an address. If it is an address, only then you can give an asterisk. That means here I am able to give an access, means A is going to be nothing but an address. Fine. Let's see what will be the value of those, or what are those addresses. Okay. So to display those address, I'll display an hexadecimal value. So by giving a percentage X, and here you can give A plus I. Okay, A plus I. If A value is 1000, so then 1000 plus 0 is going to be 1000. When I value is 1, 1000 plus 1 is going to be 1002. But usually for my reference I have given as 1000, 1002. But internally it's going to be an hexadecimal value. Okay, it's going to be like FFE3 level. So we'll see what is the output going to be in. So I have, for displaying hexadecimal value, I have given a percentage X. And instead of giving asterisk A plus I, am just given only A plus I. A plus I means going to be an address. A, if it is an 1000, 1000 plus 0 is going to be 1000. That 1000 is an address. That address will be displayed. Next it's going to be 1000, 2004. So I'm displaying an address. Let's see, compile this. In this, I'm trying to display an address, that is A plus I. Okay. So if A is 1000, 1000 plus 0 is going to be 1000. Next time when I value is 1, 1000 plus 1 is going to be 1002. When I value is 2, 1000 plus 2 is going to be 1004. But in this code block editor, the code block C language, integer is going to occupy 4 bytes, not 2 bytes. Okay, so that means whenever you increment an integer pointer, it gets incremented by 4. Okay, so let's run this and then see what will be the output. So it's asking for the values. We'll give the value here 10, 20, 30, 40, and 50. And you can check out here, the starting address is not 1000, it is 0022 FE F8. F8 is the first location. 8, 9, A, B is for first location. And from C it will start with the second. C, D, E, F is for the second location. Then it starts, third element will start from 00. From 00 to 03 will be for the third location. It will start. The fourth will be starting from 04. So each time you increment an integer pointer, it's getting incremented by 4, because in code block integer is going to occupy 4 bytes. Okay, fine. So that means these all are working. That means here if I give it A plus I, it is turning out to be an address. That means A is nothing but an pointer. This proof, that is arrays are nothing but pointers.